Hi there, my name is Ross Maximitz. I am part of Group 16, and these are my group members.
Hi, I'm Nicholas Miranda.
Hi, I'm John Redinger.
Hey, I'm Daniel Castro.
So to start off today, we're going to go through what the actual simulation looks like and what it does and the different processes that it goes through. And then we will go through the distributions and some of the data behind it, as well as the results when we ran the simulation for a one-off and also the 100 trial experiment. So to start off with, in this simulation, we have the truck source here, and that goes to 4 different transfer nodes. So we have dock A, B, C, and D. So we'll zoom in on dock A over here so we can kind of see things a little bit better. So from this dock here, so as you can see, truck comes in and we'll go into a dock number. So let's run this while this happens. So the dock brings over the entity into a dock, at which point it goes into our pallet separator. Inside the pallet separator, it will make copies of the entity that comes in into a quantity of number of pallets. So this changes randomly from entity to entity, shipment to shipment, and then the processing time is also dependent on that number of entities times the triangular random distribution, as you can see on the screen. So this pallet separator uses the receiver node, uses the receiver as a secondary entity, and then from there we actually have an add-on process called pallet separator entered. So to see what that looks like, we'll go over here. So pallet separator entered is down here. So it decides whether it's a shipment. This is important because that helps decide whether we're actually sending a receiver to a dock or to a holding dock or the shipment itself. So we only want to send the shipment, so that's why is receiver, or is it a shipment, equal true. And then it'll set the node equal to the holding dock will equal the dock number. So it goes back to the dock, holding dock that it came into. So back to our facility. So as you can see, things are getting processed here. So since it's only 1 a.m., nothing's getting processed thanks to our work schedule that we can see over here. Our work schedule follows a standard work week for our all of our workers, which is Monday through Saturday, starting at 7 a.m. So we'll speed this up a little bit. So now we can see that our put-away operators, which are these forklifts, are getting to work. So they come in to a dock, to a holding dock, they pick them up, and then they go into whatever aisle they need to. So they're following a path here. So the aisles alternate whether they can go up or down. So the forklifts find the shortest dock or the shortest route they can to whatever aisle they need to go to. So if they're going up one and then down and then back, they will also they travel from dock to dock over here, and over here we actually have the robot, the AGV. So 25% of the pallets coming out of dock number or dock D goes through the AGV. So they're not moving because there are no entities for them to pick up. So these AGVs, we'll go ahead and stop the simulation so that we can talk about the AGVs a little bit. So the AGVs, again, they have a ride capacity that's random, and some of them, and they dwell until full. So because the ride capacity is random and it rounds up, we're able to specify how many they pick up each time. So these ones, they pick up an average of 2.5 pallets per carries. So that's why that 2.5 is there. And then it has a minimum of 1 and 10. So they're dwelling until that they fill up what they need to fill up. And then they go into whatever holding dock they need to. So that process actually looks different for dock D. So at dock D with AGV pickup right here, it decides whether it's a shipment. Again, we're trying to assign things to shipments. We're not trying to assign things to a transporter or a worker. So we're seeing that it's a shipment and we're setting its node to an aisle, to actually aisle instance property here. But what that is it's actually the up or down part. So if you look at our tables under right up here, so aisles, so the start aisle right here, so you can see 10, it moves up 10, down 12, up 14. So that's where the AGV is actually going. So once it's at those places, there's another, we'll go up 10 to start with. So here, if it comes, anything that comes through here, if it is not a put away operator, so PAO, it will have to ride on the replenish operator. So in here, that's what's happening with the AGV, and the AGV is not a put away operator, so then it's going to ride on the replenish operator, and it goes through this AGV drop off process. So this process is up here. So we start off by looking at whether it's an AGV, because again, we don't want to mess with the put away operators. Those are going directly to the aisles. So it comes here, is it an AGV? Yes. And then we're only going to affect the shipment on the AGV, and then we're setting that aisle node to the end aisle sync, not just the end that we're currently sitting at. Okay, so I'll come back over to here so we can see this a little bit better. So again, workers, the entity shipment comes in, comes up to dock D, transfer 1, and it splits up into a 0.25 to AGV, a 0.75 to put away operator for just this dock. Dock D is the only dock that can currently handle these robots. And then they go on to their process. So to kind of show you what some of those processes looks like, or what some of those pathways look like, we're going to view networks over here. So aisle path, these aisle paths the put away operators can ride on. So as you can see, they go pretty much anywhere. Every single path in the aisles are lit up that way in that gray color that you see. If we change it to, let's say the robot path. So as you can see, the robot can move up and down along these bottoms. It comes up the AGV, and then it alternates the aisles that it comes down on, because it can only move up aisle 77. Okay, so just to kind of look at this one more time, we're going to run this at a good speed. We're going to do 500 speed so that we can see everything. And we're actually going to play this in 3D as well. So as we're waiting here, it's at 1:30 right now. So as you can see, these shipments are showing up here and then going out to the pallet separator. So we decided to put that pallet separator off to the side so that it just looks a little bit cleaner on the docks. So it does the same thing as if we were just to have a separator at each dock, but this way it just looks cleaner and is easier to view and model. Whenever we need to change one thing, we can just do it on one separator and not the 30 something that are listed. So we're going to come over here and we're going to try making sure we're not clicking on anything. So as you can see, the pallets are coming up and down each aisles. Okay, and then there's our replenish operator moving around, moving things from the end of the aisles as the robots bring them in into the aisle sync. Okay, so we'll speed this up a little bit more so we can kind of see more of it. And if we wanted to, we could also change the symbol of the pallets and the shipments to make it look like a pallet, a full pallet, but we just kept it for simplicity's sake as the green triangle default. So now that we've seen that run, we'll fast forward it, and then I'll hand this off and we will talk about the distributions next.
Alright, I'll go over the methods we use to organize and analyze the data in Excel. So this is the historic data we were given. What we did here is basically we made a week count. So this is the week number within a year. So this is week 6. This is the day of the week of the corresponding week, as well as the hours. So with this data we were able to understand at what time, precisely what day of the week we were receiving certain shipments. This is pretty much what we added onto the last table. We did a graph here, and we can see the pattern repeating itself all over again because we have the same working hours as well as the same days in a week. So that's why the pattern repeats all over again. Here what we did was we did a pivot table with the row label, so the number of rows we had and how many entities they were receiving in an hour. Here's a histogram picturing the data from the table. Here is the cases count pivot table as well. So this is basically what we did was we took the received shipment number and then we did a case count. So this is how many cases were in this shipment. This is a graph explaining how many cases within every shipment we had. We can see that's very there's just a few points that are spiking out, but it's pretty much a pattern all over the simulation. Here what we had is basically this is like a map, but set up in like a table form. We had which items will go to which rows and which aisles and which rack numbers. So this is pretty much telling us where to go and how to organize the shipments that we're getting. What we did here, this is the probability. We did a probability function distribution. So what it is this bin edges is pretty much how frequent are we receiving 10 shipments. So we got 77. From 10 to 20 we got 165. From 20 to 30 we got 269, so on and so forth. And then here we can see that we have the probability. So the probability of receiving 77, it's 9.07%, and then we have the cumulative distribution going down to 100. On this graph we can see the frequency as the bars and then the cumulative probability as the orange line. And then now I will leave it to Nicholas so he can talk about the results.